In this lesson, we're going to continue to factor. Yesterday, or in the last lesson, we learned how to factor a binomial. We found the greatest common factor between the two terms and we pulled them out, we divided them out. Today, it's going to look different. Let's reminisce in the past to when we had problems like this. X plus 2 times the quantity x plus 5. To multiply two binomials, we could use FOIL. So I'm going to do that real quick. X times x is x squared. X times 5 is 5x. 2 times x is 2x. And 2 times 5 is 10. Combine my like terms. I get x squared plus 7x equals 10. Okay, so this is what we're going to be doing today. We are going to take this, our answer that we've gotten before, and we are going to factor it to look like this. That's our goal. So let's try this problem. I know we already know the answer, but let's see how we get there. Today, they're going to give us x squared plus 7x plus 10. Our goal is to factor it. When you factor a trinomial, you're going to notice that you cannot do what we did in the last lesson, and you could not pull out a common factor between all three of these. So instead, you're going to set up two sets of parentheses. You're going to have a binomial times a binomial. These first places right here, you're going to get from your first term. Think of FOIL. What we did here is we did first, we multiplied these two to get this term. So what times what equals x squared? Well, x times x equals x squared. It's trickier for the last two terms. This term and this term is kind of like a puzzle. You have to figure out what multiplies to be 10. So what two factors make 10? 1 times 10 or 2 times 5. But those same factors add to be 7. Okay? To keep our thoughts organized, I'm going to create a t-table. You want to multiply to be 10, but add to be 7. Oops. So what two factors can we use to make 10? Well, before I said 1 times 10. But those two factors equal 11. So this will not work. Think of another way to make 10. We can make 10 by 2 times 5. Well, 2 plus 5 is 7, so this will work. Notice I have a positive 2 and a positive 5. So x squared plus 7x plus 10 factored is the quantity x plus 2 times the quantity x plus 5. Let's do some more of this. Let's try x squared plus 3x plus 2. You're going to break this into two sets of parentheses. To get your first term, you're going to multiply something times something to get x squared. Well, that's x times x. To get this last term, in both sets of parentheses, you need to multiply to get 2, but add those factors to get 3. So I'm going to set an organized chart up over here. I want to multiply to get 2, but add to be 3. Think of ways you can make 2. There's only one. Do those factors add up to be 3? Yes, they do, so they work. I have a positive 1 and a positive 2. That was an easy one. Okay, now it's your turn to try, to experiment, to see if you get this. Try x squared plus 8x plus 12. Push pause and try this now. Okay. Don't give up. If you gave up, you should try a little harder. This is like a puzzle. You're going to have to guess and check sometimes before you get the answer. To get this first term, you need to think what times what equals x squared. To get the last terms in both binomials, you need two factors that multiply to be 12 but add to be 8. So to keep my thoughts organized, I make a t-chart. Two numbers that multiply to be 12 but add to be 8. So I'm going to go through the factors of 12. 1 times 12, well, that adds up to be 13. That doesn't work. How about, what if we try 2 times 6? Well, that adds up to be 8. So it must be x plus 2, x plus 6. Let's try a different problem. now I'm going to add in negatives. Our answer is still going to be two binomials multiplied by each other. Our first term is still going to be the first term multiplied here. Something times something is n squared. And to find the last two terms in the binomial, you are still multiplying to get this term and adding to get this term. Set up your t-chart. Think of two factors that make a positive 6. Well, 1 times 6, when added together, that's 7. Okay, that doesn't work. How about 2 times 3? Well, when you add that together, you get a positive 5, and we need a negative 5. That does not work. What else would we do to get a negative 5? Well, what if we do negative 2 times negative 3? Same sign sum. These add up to be a negative 5. So this is actually n minus 2, n minus 3. Think about FOIL if we were to check your answer. Firsts, this is for checking. Firsts, outers, innards, lasts. Combine your like terms. Okay, our answers match, so this is correct. Okay, let's try another one. X squared minus 4x plus 3. You're going to factor this into two binomials. Your first term is the first term in the binomial. Something times something is x squared. To get your last terms, you have to multiply to get 3, but add to be negative 4. Okay, so we want to multiply to be 3, but add to be negative 4. Oh, this should say add, not by. Okay, so the factors of 3, the only way to make 3 is 1 times 3, but when we add them together, that's a positive 4, so you're going to have to play with negatives. What if we do a negative 1 times a negative 3? Isn't that, when you add them, a negative 4? Your turn to try n squared minus 6n plus 8. Give that a shot. Push pause and try that now. Okay, I have 2 more types of problems for you. The next type. N squared plus n minus 20. You're going to notice now the negative's in a different spot. You still use the same process. To get your first term, we do m times n. To get these last terms, you need to multiply to be 20, but add to be 1. Hopefully by now you're starting to see some patterns. Okay, so we need to multiply to be negative 20, but add to be a positive 1. So multiply to be negative 20. So that means we could do negative 1 times 20, but that adds to be 19. So that doesn't work. Or 1 times a negative 20, that adds up to be negative 19. That doesn't work. We could try 2 and 10. Negative 2 times 10 is 8. Or 2 times a negative 10, that's negative 8. That doesn't work. How about 4 and 5? negative 4 times 5. Oh, that's a positive 1. So my answer would be m minus 4 or m plus 5. Now, if you're wondering if there's a certain order, if you can put plus 5 here or negative 4 here, that's okay. It doesn't matter what order they're in. Try w squared plus 6w minus 16. Push pause and try that now. Okay, last time. We have y squared minus 7y minus 18. Same deal. You're going to factor this into into two binomials. Your first term is y squared multiplied. Your second terms, you need to multiply to make a negative 18, but add to be a negative 7. So let's get our chart be organized. We need to multiply to be negative 18, but add to be negative 7. So think of ways to make 18, negative 18. Negative 1 times 18, well, these added is 17. Or 1 times a negative 18, well, that's a negative 17, so that doesn't work. What about 2 and 9? Negative 2 times 9, oh, that's a positive 7. We're getting close. What about 2 times a negative 9? Well, that's negative 7. That works. Positive 2 and negative 9. Again, you could switch these. You could have the quantity y minus 9 times the quantity y plus 2. You try b squared minus 5b minus 14. Make sure to write down any questions that you may have.